What's up, guys? Today we're going to be solving Search a 2D Matrix. Go ahead and play some music and let's get this shit done. Okay, so we're given a 2D integer matrix. So just kind of like a nested list. And each row in matrix is sorted in non-descending order, which means it's always increasing. So 1, 2, 4, 8, 10, 11, 12. As you see, 2 is bigger than 1, 4 is bigger than 2. And we see that 10, the row below it is always going to be bigger than the row above it. Okay, see the first integer every single row is greater than the last integer of the previous, which means that 8 is always going to be smaller than 10. This 13 right here, because it's in the last index, is always going to be smaller than 14, which is in the first index of the second row, or the other row after it. Yeah. So we just have to search if our target number is inside this matrix. For example, 10 is our target matrix. We could just look at it. We see 10 is right there. So we know we could return true. And for this, our target is 15. Do we see 15 in here? No, we don't. So that's why. Okay, let's go ahead and search this 2D matrix and solve the question. So initially, what we could do is we could look at this row right here, this last row, or this first row, and compare it with target. When we look at the last row, we could check if this row right here is bigger. So the index 0, the column 0 should always have, or I'm just going to call it column 1 because it's easier. So column 1 should always have a number which is greater or smaller than our target. Otherwise, if it's like, okay, if we're searching for 10 and we see that 14 is greater than 10, this row, there's no point of searching it because we know that everything after it is going to be bigger. But we're looking for 10, which is smaller than 14. So we could just eliminate this whole row. Right here, we could go ahead and just write that out. So I could start off by saying, getting rows. So I'm gonna say rows. You gotta get the length of rows, which is this the first part of the matrix. We could do it length of matrix. And now we have to get how many columns we have. And we're guaranteed that our matrix right here, our matrix is, let's see, matrix length is at least n. Wait, yeah, see right here, we're guaranteed to have at least one entry inside the matrix. So I'm just gonna say length matrix at position 0. So just row. It could be any row, but row 0 is guaranteed to have something in it. That's, you can see the constraints right here. Okay, now we could make a pointer because as you see right here, we're looking at just like the ends, and we're just looking at each row, but not the contents in the middle of the row, kind of just like the top and the bottom. So we can do something called top and bottom. So top would be equal to 0, and bottom would be the amount of rows that we have. And how do we get the amount of rows? We could do that by doing the um length of columns minus 1. Because we're going to be searching through this kind of like a pointer, and it's 0 index. That's why you have to subtract 1 right here. Now let's go ahead and write our conditions. So like what I was saying earlier, when we see 10 right here, or when we see 14 and we'll compare it to our target, which is 10, we can see that 14 is larger than 10. So we could just eliminate that whole row. Let me go ahead and write this while condition. Top should always be less than bottom. I'm just gonna say top pointer. Less than or equal to bottom pointer. Let's go compute the middle. Um, we want to point to the middle row. That's our binary search. Okay, now we could say we could go through the matrix at this current row. And let's go ahead and check this left portion. So this left portion is always going to be 0. And we can make this into an if condition. If target, which is our 10, is, let's say, less than. Actually, if target is greater, right? So for example, this 14 right here, and I highlight it. Okay, yeah, this 14. If our target, which is 10, is greater. Oh, actually, less than. No, greater. Okay. So if our target 10 is greater than 14, then we could just eliminate this whole entire row just because we know we're looking for a number which is smaller than the first element of that row. So we go ahead and just say we're looking for a smaller number, so we could de-increment bottom pointer. So bottom pointer is now equal to the current row minus 1. The other condition would be we have to check this right here. So our last pointer right here, or the last number in the row, which is like, let's say let's go check 8. Okay. Okay, so if we have the number 10, right, and we're checking the last index, and it's 8, we know that our number 10 has to be greater than 8, right? If it's less than 8, then we know we're not in the right row, right? For example, if I compare 10 with 8, and then 10 is greater than 8, why would I check the row for a bunch of numbers which are smaller than 8? It's already guaranteed that 10 is not there. Just because 10 is not smaller than 1, 2, or 4. Because everything under 8 is going to be smaller than 10. So why check that row? And that's why we're writing this condition right here. So if this target is going to be greater than matrix at our current row, and since we're at the last index, right? We checked the first index to see if if our number was smaller than 14 or smaller than this. And now we're checking the right index to see if it is larger. So this is to check that index, we do -1. And if it's not true, we want to go ahead and move our pointer and cut our search in half. And we could do this by doing top pointer is equal to current row, and we +1. Kind of like searching this. So we search this, it's not correct. Then we do current row, which is the current row that we just searched, +1. So now we're on this row. And if those two conditions pass, then we go ahead and just break. Because then we know we're in the right row. Right? And if we never find it, that means left pointer is equal to right pointer. Let's see. Oh, actually, right top. That means element was never in our array, because it's definitely possible to have the element not in the array. Well, I could run through this right here. So let's say our target is 15, right? We start in the middle, because that's what we did right here to find the current row. Divide by 2, get in the middle, because top is 0, and then bottom is 2. So that's 2 divided by 2, and that's 1. We'd search this array. So we first check this bottom one. Is 15 greater? Um, so is 15 greater than 10? Yes, it's greater. So we know we're in the correct row. And let's go check the second condition. Is 13? Yeah, is 15 greater? Because we're looking for 15. Is it greater than 10? That's true. Okay, hold on. Let's go back to this 10. Okay, so 10. Okay, so 10, we could go ahead and check it by starting at this row because that's the middle row. And our target is going to be 10. Or actually, let's go check 14. Okay, so 14 would be, is 10 greater than 14? Um, no, it's not. Okay, I think this is actually correct right here. I messed up the pointer. Go ahead and do this now. Okay, so 15. Okay, let's go run through this on, and I kind of don't really like these use cases just because the answer is already there. I wish it was a larger one so we'd have like the worst case fail, but we can go ahead and test it. Okay, if target is greater or less than, so this is gonna be false. It's gonna be false, so we know we're in the right. Okay, but this one, okay, let's run it for this. So we search row 10. If this target, which our target is 15 for this one, if 15 is less than matrix current row, which it is, it's not less than, it's actually greater. So we go ahead and do bottom current row plus 1, current row minus 1. So we'd bring that over here. We'd compute um, this top plus this bottom. So 0 plus 1 would be 1, and 1 divided by 2 would be 0.5, but we use floor division right here, so we check this row right here. We check 1. So when checking 1, we see is target, which is 15, less than matrix. Let's see. Yeah, it's not, it's greater, right? So we see that target 15 is actually bigger than the matrix. Wait a minute. Okay. We do 15. 15 is right here. Wait, okay, so target, if target is less than matrix, current row 0. Yeah, 15 is not less than that, right? So we check the other, is target greater? This is target greater. Yeah, it is. So we bring that actually down. And then we do 1 plus 2 divided by that. We check the same row again. Now left and right are on the same thing. So that's why if, yes. So we know we're in the right row. But none of these conditions are satisfied. So we just return false. Yep. Okay. Yeah, now after finishing this, and it doesn't hit false yet because we hadn't hit the return statement, we could assume we can now assume that we are in the right row. Now we go ahead and search that. Okay, we could say we could have a left pointer. I set it equal to 0. Right pointer, we could set this equal to the length of a row. Or the length of a row is actually just a column. Right, so left pointer is going to be right here. Right pointer is going to be right here. So say we have 1, 2, 3, 4. We have 4 columns. So that's gonna be 3 index. That's why we're doing column -1. And now we could run our while condition. Say while left pointer is less than or equal to right pointer. You go ahead and compute the middle. So middle pointer is equal to left pointer plus right pointer divided by 2. And now that we know that we're in the right row, this is guaranteed because we already ran this algorithm right here. Yeah, looks like we named the current row like that. Okay, we're gonna go ahead and search the current row. Okay, now we could check the statements say if target is greater than current row, we go ahead. So if target is too big, we should de-increment the right pointer because we want to make the number smaller. So we do right pointer minus equals, or right pointer is equal to middle pointer minus equals 1. And the other condition would be else if target is less than current pointer, current row at the middle pointer. Then we could just do right pointer, or we could do left pointer because it means target it's smaller than the current row. So okay, for example, we're searching through this. We're in the middle. We see 11 is right here. Our target is 10, so we know our target is smaller. Okay, I'm gonna mix them up. This should be greater. So we want to increase the number. So left pointer plus equals, or is equal to middle pointer plus 1. Okay, and else return true. Because the other possibility could be that it is target is equal to current row. We could also just write at this. It might be easier to look at. And I think this should be correct. Let's go ahead and test it out. And we ran to length of columns. Let's see, where was that? Oh, we ran to another one. Okay, let's see if target current row at middle pointer. Current row. Current row is this okay. It's actually supposed to be like this. Okay, let's go ahead and test it out now. And okay. My output was none. Hmm. All right, I'm actually not sure what went wrong here. Go ahead and look it up. Multiple stuff. Okay. Mm, you're right. Mm, should recompute this after the loop. Column search loop. That's this one right here. What if I take this out? I feel like it'll still run correctly. No. Mm, looks like I got like the base correctly, but in this condition, I did not think of this. Yeah, same thing with this. I was thinking equal, but because we already have equal right here. Ah, I saw some syntax errors. I'm gonna show you guys the other solution you could do. Let's go ahead and take this out. Another solution we could do actually is running a running this. So um we could do an answer, or actually to array. We could turn this matrix actually into an array. So for row in matrix, we could do matrix to array dot ex extend it by row. So now we have a long matrix, a long array. And for this we could do, let me go back over here. And from this we could run a binary search. So left pointer is equal to 0, right pointer is equal to the length of matrix to array, and -1 because it's 0 indexed. Now we run our while loop while left pointer is going to be less than or equal to right pointer. We could just go ahead and compute the middle. Middle pointer will be equal to left pointer plus right pointer, and divide that by 2, and now we get matrix to array. And we can set this at this middle pointer. We check if it's equal to target, and if it is, then we can just return true. We could also check the other conditions. say this is less than target, then we want to actually increase. Um, oh, I forgot the if. Let's see if matrix array, if target is actually greater, then we want to go ahead and increase this. So I could do um, target is bigger than that, so we can make our left pointer is equal to middle pointer. We want to increase it, so by increasing it, we could do that. Our left pointer is incremented by 1. We also do elif is if target is smaller, then we go ahead and try to de-increment the right pointer. And then, yep, and if we run this whole entire thing and we never find the number, then we could just go ahead and return false. And yep, that's a more simple solution, but I think what the interviewers are looking for, if you ever do it, is to just, this might be a more clever solution, but I think they're looking just more for binary search, just so they want to see you do 2 binary searches on top of each other, more than just one simple one. But yes, that's how you solve it. See you later, guys.